The two forces of gravity and electromagnetism seem at first sight to be sufficient to explain everything we see or feel in our everyday world. But once we look inside the atom, it is immediately obvious that other forces must be at work in the universe.
By the mid-1930s, we knew that atoms are composed of electrons orbiting a nucleus of protons and neutrons. But there's a problem with this model because protons are positively charged. And so when they're close together, the electromagnetic repulsion should blow the nucleus apart. And that's not what happens, of course. There must be another force many times stronger than electromagnetism that glues the nucleus together. And that force is called the strong force.
The strong force is not only responsible for holding the nuclei of atoms together, and without that, every atom in the universe would just spontaneously explode. But it's also, and this is quite interesting, responsible for 98% of nuclear mass. That means 98% of my mass, your mass, the mass of the Sun, the mass of the Earth. And we don't quite know exactly how the strong force generates that mass. And so we want to study that in more detail.
The discovery of the strong force was a giant leap forward in our understanding of nature. But there were still phenomena that we couldn't explain. This is a PET scanner, and it's transformed the way we diagnose many diseases because it allows us to look inside the body and detect abnormalities in cellular activity. Machines like this were developed as a direct result of advances in particle physics. The P in PET stands for positron, an antimatter electron, identical in every way except it has opposite charge.
Positrons or electrons are emitted from the nucleus in radioactive beta decay.
And that's a process that baffled physicists throughout the early 1930s. And they knew that the nucleus was made up of protons and neutrons held together by the strong force. And they knew that beta radiation came out of the nucleus. They also knew that beta radiation was comprised of electrons. So where did the electrons come from? It was the Italian giant of science, Enrico Fermi, who finally solved the problem. In 1934, he proposed that there's a weak nuclear force that can convert protons into neutrons or neutrons into protons, at the same time emitting electrons or positrons and neutrinos from the nucleus. Fermi had found the missing force that explained the inner workings of the atom.
He played a huge role in nuclear physics, and his weak force has played a huge role in us being here. In fact, it's critical that it's so weak because it controls the first stage of the Sun's fusion cycle. Because it's weak, the Sun only just keeps alight. It's been burning for 5 billion years already. If the weak force had been any more powerful, the Sun would have burnt out before any of us got here.